I'm Simon.
I'm Bao.
I'm Jason.
And I'm Dave, and we're Team 4 Dresden.
We've come together as a team to solve a real-world design problem working with Dresden Optics.
In this video report, we'll cover our design process and the interaction between teams and clients.
This video is aimed at a fellow engineer as a learning resource and guide.
Overall, this project explores the human-centric aspects of the design process.
The project started with a design brief. Dresden Optics is a rapidly expanding company that produces sustainable, affordable eyewear. The final stage of manufacture happens in store, where optical blanks are shaped by a machine called an edger, which grinds off unwanted portions of the thermoset resin blanks to fit the glasses frame. The waste from this process is a mix of ground lens and water. Water is used as a coolant and lubricant. The slurry collects in a holding container under the bench and the water is recirculated with the waste settling to the bottom. This container needs to be emptied periodically, and this is a messy and time-consuming process. It also has to happen in a busy store. The waste material is not recyclable from a conventional perspective, and Dresden wants us to find a way to separate the waste as efficiently as possible to enable its reuse in other industries. In our design methodology, the first step is the understand stage. Here we aim to understand the engineering problem and context where it exists. This involves getting deep into the problem to understand it from different perspectives and recognizing that the client's needs and expectations are often not explicitly expressed. After some initial research, we organized a structured interview with our client, structured in the sense that we had prepared questions to ask and answers that we needed beforehand. This helped fill gaps in our understanding. We adopted a tool called the beginner's mindset, which involves constantly making sure that we are actively listening. By not jumping to conclusions or succumbing to preconceived ideas, we can pick up on finer details of the customer's wants and needs, keeping in mind that this stage of the framework is about understanding, not forming solutions. We received feedback from Dresden about the previous UTS solution and analysed the successes and failings of the design. Staff said that it worked well, but it was complex to use and it had broken down. We understood that simplicity and user-friendliness was key to the design. We completed a customer value chain analysis to map out key stakeholders and the relationships between them in terms of resource transfer. This allowed us to better understand the project from the perspective of each stakeholder and gave us a tool to effectively communicate key issues in a targeted manner. In the translate stage, we took our broad understanding and condensed it down into concise engineering specifications. This defines the project we set out to solve and facilitates direct communication of these specs to our client, which led to a consensus of project scope and client expectation. We wrote a problem statement and made up a table of design expectations, which are concrete specifications that our solution would achieve. We then formed the evaluation criteria, detailing how we'd test and verify that these expectations were met. It also helped us form a list of deliverables that Dresden expected from us to submit at the end of the project. These deliverables are a working prototype that can be used immediately, CAD models and drawings to the standard that allows manufacture of units by a third party, including a bill of materials and comprehensive build instructions, a user manual aimed at non-technical users of the filter that was easy to understand, and a complete digital resource of all the materials we had generated. With our design specifications completed and approved by our client, we moved to the next design stage. In the ideation stage, we generated ideas on how to solve our design problem. To start, we did a brainstorming exercise to generate lots of ideas in a short amount of time. A key to success in this process was not to evaluate the ideas, debate or shoot them down, but just get them down quickly in a free and creative manner. We then grouped the ideas we'd generated into categories and built a morphological chart. This allows the formation of discrete concepts. From this table, we generated 5 concepts and compared them with the previous solutions by UTS students. But what makes the morph chart powerful is its ability to communicate designs in a simple and tangible way. With this in mind, we organised a meeting with Jason, co-founder of Dresden, and Jody, the Sydney Regional Manager, and did a pass on the morph chart with their input. This was great as it involved two key stakeholders and made them an integral part of the design process. It opened a technical dialogue and helped align our design direction with their expectations. We'd highly recommend this approach to future teams. This meeting also revealed a complication. We found out the Huvitz brand edging machines were to be gradually replaced with Nidec units. We resolved to make our solution fit either model of edger and so amended the design requirements to suit. With a clear sense of direction, we modelled our concepts using CAD and advanced to the next stage. In the prototype stage, we built a physical prototype. In this case, a prototype is not meant to be a first attempt at a final solution, but a proof of concept and vehicle to test different design features. We set up our prototype for testing. We tested maximum flow rates with clean water, flow capabilities of different pumps for our active filter designs, filter overflow and bypass operation, and the effects of waste loading on filter flow rate using lens waste collected in store. We designed a device to split flow evenly under variable flow rates for a dual filter system. And we tried leaving the pump on overnight with interesting results. This idea might warrant further investigation. With our main concept proven, it was time to install the prototype in store to test its real-world performance. The new Haymarket store was less busy than the main Newtown store, and our contact Massini was exceedingly helpful and accommodating during the testing period. Installing the filter in store allowed us to observe the effect of increased waste loading on the filter's flow rate. Initially, the felt filter performed well. However, after 60 lenses were cut, the filter clogged enough to take 20 minutes to empty. This meant that only one lens every 10 minutes could be cut, and our target was 5 minutes. The filter was going into failure mode, where unfiltered slurry overflowed and bypassed the filter. It was time for a rethink. Through further research and testing, we found a different filter media type. An open weave construction was less prone to clog and enabled the filter to operate in dynamic mode, even with continuous back-to-back lenses cut, which was the most extreme load on the filter. With 4 weeks of testing time in total, we generated lots of data and end-user feedback, which helped us iterate the finer points of our design. As we were testing, the final CAD model was updated until we were ready to start fabrication. We laser cut some MDF for the base plate and filter carrier to check our model dimensions against real life. To make sure, we test fit the penultimate prototype in the Haymarket store and then moved on to the final build. Our design for manufacture approach worked well and the build went smoothly, with all the complex parts being 3D printed or laser cut. There are a few iterations of part dimensions but no major changes. With the build and deliverables complete, it was time for project handover. We met Jason in the Haymarket store to present our solution. He was happy with the aesthetics of the filter and asked a lot of questions. We outlined our build process and explained the design methodology we followed. He said that he was impressed with the simplicity and scalability. We installed the filter and Massini cut a set of lenses for a client. She said that she was very happy to see us back as she had been manually cleaning the tank for the last 2 weeks. Jason said he was very happy overall and wants to test the filter for a week to analyse its performance. If it performs well, he wants to install them in all of Dresden's stores. We left handover feeling happy we'd met Dresden's expectations, we'd learned heaps, and we'd built a strong and effective team.
We hope you've enjoyed our video.
In the end, the project was a great success. The tool and technique we used worked really well for us.
By following the design process as a team, we were able to deliver a solution that met the client's needs.
We'd like to thank Jody and Jason and Massini from Dresden, and Mark and Ben from UTS for their help.
Thanks for watching.